We often talk about IQ like it's a single number, one score that defines our intelligence. But where did this number come from? What does it really measure, and why has it been used in both situations ranging from classrooms to courtrooms, for both supportive guidance and for some of the most repugnant forms of discrimination? In this video, we're going to unpack that complicated and often controversial and almost always messy history of intelligence measurement. From phrenology to psychometrics, from military selection to educational interventions, from cultural bias to the rise and fall of IQ across generations, we are going to explore how intelligence has been measured and what those measurements mean in all of those situations. And for those of you watching the extended version, we're going to finish our discussion with the 7 biggest issues that I have with IQ testing. G'day, my name's Luke Rowe and I'm a researcher and lecturer, and one of my specialty interests is in human cognitive abilities, otherwise known as intelligence. Now, a subtopic of that is the measurement of intelligence, and that's what we're about to discuss. So let's begin at the beginning of that scientific enterprise in the measurement of intelligence. Now, to orientate ourselves, we need to rewind to the 1800s, where one of the earliest figures in the story of intelligence was Franz Joseph Gall, the German neuroanatomist who pioneered the idea of localization of brain function. And he suggested that different mental faculties resided in different parts of the brain, which was at the time a groundbreaking idea in neuroscience. But then it took a bit of a step too far, or a bit of a dark turn, when Gall proposed phrenology, the pseudoscientific belief that the bumps on your skull could reveal your intelligence, your personality traits, and even your moral character. And while phrenology has long been debunked, Gall's idea that different parts of the brain serve different functions laid the groundwork for modern neuropsychology and neurophysiology. And that's where Francis Galton comes into the equation. He was the cousin of the famous botanist and founder of evolutionary theory, Charles Darwin. Now, Galton tried to measure intelligence using reaction times and head size, and he was the first to coin the phrase nature versus nurture. His most prominent works indicated that he believed that intelligence was hereditary, and this led him down a very dark road where he advocated for eugenics, which is a movement to improve human populations through selective breeding. And that legacy too is deeply troubling, and just in case you're wondering whether it's good or bad, it was very, very bad, and it serves as an example of one of the most egregious misuses and abuses of science to this day. Now let's skip over to the early 1900s in Paris, where Alfred Binet and his student Theodore Simon created the first practical IQ test in 1905. But unlike Galton, Binet's motives were educational, not elitist. His goal was to identify struggling school children who needed extra help, not to rank or exclude them. So Binet introduced the idea of mental age, the age level at which a child could solve problems. For example, if a 10-year-old solved problems like an 8-year-old, their mental age would be 8. And from there, you could calculate the IQ of this child using the following formula. IQ equals mental age divided by chronological age multiplied by 100. In this example, the child's mental age, being 8 years old, and his chronological age, being 10 years old, would result in an IQ score of 80. So if 100 means that you're on par with your peers, then 80 would mean a significant deviation below your peers, and so you'd be a candidate for extra educational supports. Now that sounds pretty noble, right? Well, this idea gets a little messier when it crosses the Atlantic and IQ tests find their way into the USA. And this is where the psychologist Louis Terman comes into play at Stanford University, where he adapted Binet and Simon's scales into the Stanford-Binet test of intelligence. Now, I've actually got a copy of this behind me in my bookshelf, one that Terman authored himself, and his interpretive notes are all still in there. So it's been a long-standing test that was circulated across the world. Now, what became obvious to Terman and his colleagues at the time was that the original IQ formula only worked for children, but not for adults. And this was because mental age stops increasing significantly after adolescence and stabilizes in early adulthood. Whereas chronological age, that just keeps on rolling and rolling on. So if you're 30 years old and you have a mental age of 30, your IQ is going to calculate to precisely 100. But what happens when a 30-year-old scores like a 25-year-old? Now, according to the formula, their IQ would be 83. And that doesn't make sense because adult cognitive abilities don't develop or decline in a linear or commensurate way. And this limitation led the psychologists to realize that the original IQ formula became increasingly meaningless for anyone after childhood. So for adults, mental development levels off, yet chronological age continues to march on, and as a result, the formula tended to inaccurately portray most adults as having lower and lower IQs as they aged, even when their cognitive functioning remained stable or even improved in certain domains like vocabulary or occupational expertise. Now, to address this issue, psychologists introduced a norm-referenced approach. Instead of comparing mental age to chronological age, the norm-reference system compares an individual's test performance to a representative sample of people in the same age or demographic group. So IQ scores are then standardized to fit a normal distribution known as a bell curve, with a mean score of 100 and a standard deviation of 15. And in this model, about 68% of the population falls between an IQ score of 85 right up to an IQ score of 115. So anyone who's got an IQ score, say 130 plus, is in the top 2%. Whereas people who are a couple of standard deviations below, they're in the bottom 2%. People with an IQ score of 70, for example, would indicate potential intellectual impairments that would merit a great deal of support and probably exclude them from a number of complex occupational settings that could put them at risk. So the new method of IQ testing and measurement provided two major advantages. First, it made IQ scores more meaningful across the lifespan, and it allowed better differentiation between individuals at high and low extremes of ability. And second, it also enabled the comparison of individuals from different age groups without relying on the flawed mental age concept. Now let's quickly take a trip back in time and across the Atlantic again, back to England, where Charles Spearman, a British statistician and psychologist, noticed something strange while studying student academic performance in schools across England. He discovered what was, at the time, quite a peculiar trend, where students who did well in one subject tended to do well in others. So, for example, a student who was graded with an A or a B on their mathematics class would also be likely to be graded an A or a B on their science tests and their science classes, as well as their English or additional language classes. And that defied expectations at the time because the general belief was that students would be markedly better at some subjects and far worse at others. So there'd be variation in their abilities across the different domains. So if you're Charles Spearman back in 1903, seeing all of these commonalities between academic achievement results at schools, how are you going to explain that phenomenon? Well, he decided to analyse the data using his own form of correlational analysis, which he was also a pioneer in developing. And he found that the students' performance across each subject was often very strongly correlated. And this is what psychometricians refer to as the positive manifold, where most intellectually challenging tests undertaken by an individual tend to correlate positively together. But Spearman didn't stop there. Using a method he helped invent known as factor analysis, Spearman proposed that a general intelligence factor, which he called G, explained that positive manifold. He likened G to a kind of mental energy shared across all of the tasks. And just to be extra clear here, Spearman's discovery was the statistical factor that explained much of the variation in academic achievement scores beyond any specific abilities. The statistical factor, known as Spearman's G, is not to be confused with the causes of that observation. However, Spearman went beyond his observations by hypothesizing that the statistical phenomenon that he observed was caused by a real biological property or latent mental trait known as G, or the G factor. So the statistical G factor and the mental property that causes it are two different things. Now that's going to be an important distinction to remember as we continue to go deeper into the detail of how we measure intelligence. Nowadays, it's fair to say that the idea of psychometric G, which is the statistical property that has its roots in Spearman's original discovery of Spearman's G, is the backbone of most modern IQ tests. And this means that if you want to design your own IQ tests, you've got a pretty clear recipe that you can follow according to Spearman. First, you borrow on Spearman's original idea by measuring performance across a wide battery of cognitive tasks. And while he measured academic performance, you'd probably want to make your measures of intelligence quite a bit more efficient at targeting key mental constructs or different mental domains and abilities, which is why modern tests are constructed to include multiple subtests that include things like logical reasoning, spatial reasoning, three-dimensional rotation, even working memory tests, recognition and recall vocabulary, and so on. Now let's take a quick look at how non-verbal IQ items like the figural matrix puzzles, such as those used in Raven's progressive matrices, actually work. Typically you're given like a 3x3 or a 4x4 grid where each square or field contains a visual element like arrows, shapes, dots, different patterns. And one square, usually the bottom right square, is left blank out of that sort of pattern of 8 or 9 squares. So below the matrix, you're given multiple options like options A to E, and your job is to choose the option that logically completes the pattern. Now the trick is solving these items lies in spotting the underlying rules that govern how the elements change across rows or columns. In the example on screen, published in 2016 in an article by Becker and colleagues in the Journal of Intelligence, each field contains an arrow and one or more circles. To solve this particular example, you're going to need to first identify the rule. And if you look carefully enough, you'll notice that the arrows and circles have a distinct pattern as you move through each row and column. So can you spot the rules for both the arrows and the circles? Have a think about it. Now, if you've spotted the rules, you'll notice that the arrows are rotating counterclockwise by 90 degrees as they move from left to right in each row. And the circles in the third column are a product of adding both the number and location of the circles from the first two columns as you move from left to right. Next, you should apply those rules from the first two rows and columns to predict what should be in the missing square in the final column and row. Now, finally, you're going to want to have an answer that is consistent in completing that pattern, which is option A. Why is that? Because this is the only option that correctly follows both of those rules that you identified earlier. And this type of item isn't about memorized knowledge. It tests your fluid and spatial reasoning ability, where you're expected to abstract patterns and rules. So it's rule-based reasoning. You've got to apply that in a logical manner to a novel visual context. Right, so it's not just rote learning and reciting what you already know and just spitting out an answer that's either correct or not. You've got to reason through it. Now this next question is a part of a number series question, so your numerical reasoning, if you will. You have to answer what number comes next in this number series. 49, 64, 81, 100, 121, and out of those options below, what are you going to pick? Well, of course, these are all perfect squares, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared. So the next one is 12 squared. So the answer is 3, which corresponds to 144. Now we're going to look at logical reasoning that is symbolic of what you'd find on an IQ test. Sophie is taller than Lily and Emily is shorter than Sophie. Which of the following statements is most accurate? Now you'll notice that the correct answer is 4. It's impossible to tell. And that's because we know that Sophie is taller than Lily and Emily is shorter than Sophie, but there's no direct comparison between Emily and Lily, so we can't determine the relative heights of the two. Now from those subtests, the next thing you'd do is generate a range of scores for each individual, and in turn those scores would be used in a modern form of factor analysis. Now, items in your original set of tests would either be retained or discarded from future tests based on how heavily they load onto the so-called psychometric G and their unique contribution to the explained variation across the battery of tests and subtests. Now, if you're like me, you're instantly seeing how this way of theorizing and measuring intelligence can become quite circular, in that the choice around which items to include in the IQ tests are themselves selected based on how strongly they load onto G, making it utterly unsurprising when future tests validate the presence of a G factor. But let's not get too far off track here, because we're going to discuss this in other major setbacks on the idea of measuring intelligence in a later part of our discussion. So as the 20th century progressed, IQ testing didn't just remain stagnant as an academic curiosity. It became a global tool used in everything from school placements to military recruitment, from hiring decisions to immigration policy making. In fact, one of the most significant turning points came during World War I, when the United States Army commissioned psychologists to develop group-administered intelligence tests, the Army Alpha for literate recruits and the Army Beta for those who were illiterate or non-English speakers. And those tests were designed to sort nearly 2 million soldiers into appropriate military roles based on their presumed cognitive ability. Now, the success, or at least the scalability of these military tests, gave IQ an air of scientific authority. And from there, intelligence testing began to be adopted in schools and workplaces, and lots of legal settings like court cases, where an individual's cognitive ability was relevant to the case under review, so mental impairments or crimes committed with mental impairments or lack thereof. So by the 1920s and 30s, IQ had become a social sorting mechanism, not just in the US, but also across Britain, Australia, parts of Europe, pretty much the whole industrialized world. But that widespread uptake wasn't always a triumph of science, and sometimes it was downright a misuse and abuse of science, and often with very tragic consequences. In the USA, for example, low IQ scores were used to justify forced sterilization under abhorrent eugenics laws, particularly targeting poor and marginalized communities. The infamous 1927 Supreme Court ruling, Buck versus Bell, upheld the right of the state to sterilize individuals deemed to be feeble-minded, with Justice Oliver Wendell Holmes Jr. declaring that it is better for all the world if, instead of waiting to execute degenerate offspring for crime or to let them starve for their imbecility, society can prevent those who are manifestly unfit from continuing their kind. The principle that sustains compulsory vaccination is broad enough to cover cutting the fallopian tubes. 3 generations of imbeciles are enough. Now, it makes me feel sick just saying those words, and it's surely one of the darkest stains in the history of applied psychology, and intelligence tests were also used in so many other negative and abhorrent ways. So in the decades that followed, IQ testing spread entirely across the world, and it appeared in schools across Australia, Europe, and later in many Asian and African countries. So some jurisdictions used those tests to help allocate scarce educational resources, while others used them as gatekeepers for opportunity and advancement, so the selection effects there. Standardized tests like the Wechsler intelligence scales, adult and child, the Stanford Binet and Raven's progressive matrices were adapted into dozens of languages and became a staple in both clinical and educational psychology. But the big question remains: if we're going to use these tests in real-world settings, especially in high-stakes settings, then we need to be absolutely certain that they are fair, valid, and culturally sensitive. So naturally, as IQ tests started spreading across the globe, so too did questions about their fairness. Are those tests truly culture-free? And if not, can we still trust what they tell us? Researchers have long acknowledged that no IQ test is completely free from cultural or linguistic influence. And after all, many subtests rely directly on culturally embedded items such as vocabulary, cultural symbols, reasoning styles that are more familiar to certain people groups than others. Robert Sternberg famously argued that intelligence is best understood within a cultural context, since what counts as smart in one society can differ in another. That said, cultural loading doesn't make IQ tests invalid, but it does mean that they must be interpreted very carefully. And the extent of this cultural bias needs to be fully accounted whenever we are interpreting the results. So, at least in my view, the solution isn't to discard IQ tests if we detect some of the cultural bias that they may have, but to contextualize their use and limit their applicability, especially when considering how to interpret their results in the context of different cultural, linguistic, or socio-economic demographic groups. Now, in these contexts, local norms have to be established to allow more valid and fair comparisons within those populations. But compared between these populations, I don't think so. That's got to be done only with extreme caution or even avoided altogether. The other alternative to careful interpretation is to reduce bias altogether. And that's exactly what some psychologists have designed IQ tests to do. For example, Cattell's Culture Fair Intelligence Test and even the Raven's progressive matrices emphasize non-verbal problem solving that's supposed to simplify focus on rule-based reasoning and abstract reasoning. That's meant to be relatively free of cultural and linguistic bias. And this kind of thinking has led some test designers, IQ test designers, to divide their tests into separate culture-free categories and culture-informed categories. For example, Raven's progressive matrices are thought to be relatively free of cultural bias, and they focus more on the ability to reason abstractly without relying directly on prior knowledge or formal education. And those tests are often accompanied by verbal tests like the Mill-Hill Vocabulary Scale, which is anything but culture-free, and instead it relies heavily on learned and culturally embedded knowledge, such as vocabulary and literacy. And that distinction has been formalized by Raymond Cattell in the 1940s, and he expanded on this with his student John Horn, who noticed that the statistical clustering of subtests fell into two broad domains: fluid intelligence and crystallized intelligence. So Cattell defined fluid intelligence as a biologically primary ability to solve novel problems, to perceive relations, and to perform abstract reasoning independent of any specific instruction or past learning. In contrast, he described crystallized intelligence as the extent to which a person has attained the knowledge of a culture. It is influenced by formal and informal education and acculturation. Now, this model can provide a useful lens through which to consider cultural fairness, since some tests have heavily emphasized crystallized and often culturally specific knowledge, while others attempt to tap more fluid, culturally neutral abilities. But it's not just cultural bias that modern test developers have to worry about. They've got all sorts of different biases to consider. So test development is a highly complex, expensive, and time-consuming process, and it increasingly involves statistical techniques to identify and remove those wonky questions that are unreliable, that are biased, or just don't align with the target construct, which is almost always going to be psychometric G. So many of those issues tend to reveal themselves using differential item functioning scores, where statistics can be used to see if items behave differently for people of equal ability from different groups, right? So you can control and keep the difficulty of the item constant, and the variation, if in those scores, must then come from non-cognitive ability related factors like demography, culture, and different forms of bias such as racial or ethnic or gender biases. And I know that in some of the IQ test items that I've constructed over the past years, we've seen major differences in how they interact with people for whom English was not a main language versus those for whom English was a main language. And this gave us some really helpful insights into how we might make our measures of cognitive ability less biased in the future for populations and groups who engage in our educational settings that come from backgrounds where English is not the main language spoken. And while in theory, culture-free tests would level the playing field, in practice, even non-verbal tests aren't entirely culture-free. So factors like motivation, test-taking familiarity, and societal expectations and norms all still influence the outcomes of IQ tests. So a child who's never been exposed to formal testing or who doesn't see the test as a meaningful thing, they might perform well below their true ability, especially if they're hungry or stressed or unfamiliar with time constraints. And then there's the deeper issue, the very assumption of universality. And this is why some researchers, such as Robert Sternberg, have argued that intelligence isn't a fixed entity, and instead it's a social construct shaped by the values and demands of a given society. And what counts as smart in a New York City classroom is going to look very different from what counts as smart in a rural farming community or a remote Indigenous culture here in Arnhem Land and Northern Territory regions of Australia. And that's why many psychologists today argue for contextualised interpretations of test scores. So an IQ of 90 in one setting might indicate different strengths and weaknesses than the same score in a totally different setting. And rather than aiming for a mythical culture-free test, the focus has often shifted to developing culturally fair assessment, tests that are valid, reliable, and meaningful within the culture that they were designed to be used in. So in short, IQ tests are not invalid because they're culturally or linguistically biased. They are only invalid when they're used beyond those contexts or compared across people groups that are otherwise incompatible and weren't intended to be part of the measurement population in the first place. So while IQ tests are not perfect, they remain useful tools, especially when thoughtfully designed and interpreted in light of the test taker's background and biases and all of the limitations I've just mentioned. Their predictive validity remains quite solid within certain contexts, particularly those where they were normed in the first place. And the key is not to claim that they measure some kind of universal intelligence in a vacuum, but to recognize that intelligence always expresses itself in specific environments in a unique way. And with the right precautions, we can still use those tools to better understand and support human learning and development and intellectual remediation, which is why they were designed in the first place. So now that we've looked at this idea of cultural fairness and cultural bias and linguistic bias in intelligence testing, let's lean a little deeper into intelligence and how it's measured psychometrically through the statistical structure of cognitive abilities. You see, IQ isn't just one score per se, it's the composite of many separate scores from many little tests or mini tests, right? We call them subtests. And these subtests typically feed into a hierarchical model of human intelligence. And the most widely accepted version, at least today, is the Cattell-Horn-Carroll theory, which organizes intelligence into three levels or strata. And at the top, the third stratum, stratum 3, represents the general intelligence factor, or psychometric G. And this is the overarching factor that influences performance across a wide range of cognitive tasks. Now, sitting beneath that in stratum 2 are the broad abilities, roughly somewhere between 10 and 15 major domains, things like fluid reasoning, crystallized reasoning, visual spatial reasoning, so mental manipulation of objects, or even auditory processing, such as analyzing sound patterns. Certainly processing speed is also a big factor. That's how quickly you can carry out simple cognitive tasks. We've got short-term memory as well, things like holding information temporarily in your working memory while you try and manipulate it or try and remember multiple things at the same time. Then there's long-term storage and retrieval. So retrieving memories over time, vocabulary testing, and so forth. Now, finally, stratum 1 consists of narrow abilities, very specific skills like spelling, quantitative reasoning, or even pitch discrimination. Now, again, we need to remember that all of this relates to statistical properties of intelligence or psychometric G, but does not directly imply that all of the tests or subtest scores are caused by one biological property, such as the G factor, originally proposed by Charles Spearman all those years ago. Now, that being said, the hierarchical model of intelligence helps test designers structure their assessments around different domains, and that ensures that scores reflect both general and specific cognitive abilities under a common theoretical rubric. For example, many modern IQ tests like the Woodcock-Johnson IQ test, the Wechsler Adult and Child Intelligence Scales, or even the Stanford Binet, they report composite scores for each broad domain and not just a single IQ score. So they're quite helpful when you want to use the test to help diagnose and potentially intervene or even remediate specific neurological deficits or cognitive impairments. For example, children with low levels of autism, they might have superior pattern recognition and inferior vocabulary skills. So IQ tests can be helpful in a diagnostic setting for them to help justify subsequent medical support offered to those children and to their families. So it can be very helpful and, again, in keeping with the original intent of IQ testing. Now, as far as scores are interpreted, IQ test is measured on a norm reference scale, as we mentioned a bit earlier, where 100 represents the average and 15 points either side as a standard deviation. So unlike a ruler though, IQ is not an interval or ratio scale. in the very strictest sense at least, and the scores, say for example a score of 130, isn't 30% better than a score of 100. It just means that you performed better than roughly 98% of age and demographic matched peers, even if those differences are, in an absolute sense, relatively trivial. And remember, just because a test measures a relatively stable construct such as a person's IQ, it doesn't mean that it reflects or even answers the question about its causes. As they say, correlation is not causation, and IQ, it is associated with lots of things like income, education, and health, but the arrows of causality are complex, and I hope I did a decent job of explaining that in my previous videos. For example, it's obvious that things like poverty can reduce access to nutrition, intellectual stimulation, and to education and schooling. And all of those will act to suppress a person's measured intelligence, their IQ. So while IQ remains one of the most predictive psychological constructs, we must interpret its scores as part of a larger, more complex cognitive system. So we've got to do it with care. We've got to do it with a lot of nuance, and always within the context in which the tests were designed and the purpose of the measurement was intended.